I wanted to make this video to share information about what I learned about engineering. Okay, so I typed out a list, and there's going to be a part 2 to this video as well, and also possibly a part 3 depending on how many topics I want to go over. But in this particular video, we're going to start off with the first thing I want to talk about, which is learning from your environment. So what I have a tendency to do, and while I'm talking about this, you'll see pictures scrolling throughout the video, is I like to, when I'm out and about, I like to look at everything from nature to construction to signage, and I like to take pictures. If there's a particular design or sculpture or artwork and I like just the design and curvatures, I'll take a picture of it and write notes about it. Or if I'm testing something out and I like the mechanics on it, like how it pushes, pulls, how a latch opens or closes, then I'm definitely taking that down in my notes and taking a picture of it. So when you learn it from your environment, you might want to incorporate some of these elements into your own design or whatever you're trying to make. So learn from your environment, guys. There's so much in this world and so many things that have already been designed, but you may be able to take those ideas and make it your own thing. So guys, look around, look at your environment, learn from your environment. Okay, so the second thing I wanted to talk about is every material is your material. This has to be one of my favorite things that I learned about engineering, because knowing what material is around you, such as things that people throw away or things that were intended to be used for one thing, but then you come up with a creative idea to use it for something else. And that is the great thing about engineering, using all sorts of materials, whether it's metal, wood, plastic, glass, whatever you're using, to incorporate into what you're trying to make or engineer. So for example, here, these are just some cutouts, and I will show a snapshot of the buttons that I made. And the purpose of this material was to take old plastic bottles, bottle caps, all sorts of plastic material, and shred them into a loose material and then melt them down into a plastic sheet, such as what's right here. And then when I can take this and then I can actually make it into an actual product. So your materials around you, whether it be pallet wood or even if it's something that's assembled, some old cabinet, you could take the sheet metal from the cabinet. It doesn't matter. Be creative with the materials around you. Don't discard or discount any material, because you can use things that were made out of one thing and turn it into something completely different. So all the materials every material is your material. Don't limit yourself to a specific thing. Every material is your material. Okay, for this next category, one thing I learned about engineering is that disciplines cross over. Okay, what I mean by that is, for example, if you are learning subjects such as math, and math is connected into physics, physics is connected into chemistry, chemistry is connected into engineering, and engineering is connected to industrial design. So, for example, if you are making, let's say, a hammer, and you want the properties to be lightweight but strong, then you might look into like an ABS or a polypropylene material that's actually plastic but is good towards impact. On the other hand, if you're looking to create something like a Nerf ball, you want it to be firm but also a bit spongy but also lightweight. So knowing the different elements of what you're trying to make will determine what discipline you use. For example, where your materials lack in is where the mechanics can pick up, such as using springs, using levels, using pulleys. These are all things and concepts of mechanics in machines, simple machines, that can be incorporated into your industrial and engineering designs. So for example, one thing I recommend that everybody picks up if you're interested in designing things is to make sure you pick up a pair of calipers. Now, I picked up these calipers, and the ones that are in here, I just used the Pittsburgh case because the Harbor Freight ones I bought broke down. But I bought a double set, and it comes with a silver and black off of Amazon. One thing I recommend is to get a good set of calipers. That way you can have some way to measure with precision. The good thing about calipers is not only can you measure the inside of a specific object. You can measure the outside of it, and you can also measure the depth, all with the same tool. So that's really useful when you're trying to reverse engineer something or create something brand new that has to fit a specific. And if it's important for items to have a specific fitment, then this tool is a must-have. Okay, so the fourth topic I want to talk about is properties and elements of a material is more important than you think. So I'll give you a small example of this. If you look up at the picture above, I built a lathe to spin wood materials such as sticks I found in the yard. These are some items that I actually spun on this lathe up here that I use with 3D printed parts, and also just a regular DC motor I had lying around. The problem is that I use PLA to 3D print the mounts for the motor, and also the mounts to hold the rod, the guide rod, when you use your chisel as this thing spins around. Now, the problem with this was that when the motor actually heated up, it actually melted the motor mount, which skewed the lathe and offset it, and then I wasn't able to use it anymore. So knowing the properties of what you're engineering, how long they last, what is their tolerance for temperature, what is their impact or tolerance, what is their elasticity. You really have to know the properties of the material that you're using. For example, you might work with a mahogany and it's different from pine. So if you're working with woods, knowing the different woods, the difference between cedar, birch, you need to know the hardness of the woods, also what their absorbency is like. So if you're going to stain something or paint something, you want to know how well those woods receive those stains or paints. But that's just a small idea, knowing your properties of your plastics, your metals. For example, with aluminum, you have the great ability of it not to rust. So for example, aluminum, steel, and copper all have different conductivity properties and all corrode or erode in a different way. And for example, aluminum is great for marine and aquatic uses because it doesn't corrode under salt. So these are some things to think about, knowing the actual properties and abilities of each material and element that you're using when you're creating your designs. Now, the fifth topic I want to talk about is learning how to create systems and also how to use them. One of my favorite documentaries is The Lego Story, and this gives a perfect example of creating a system. The Olsen family wanted to create a system to where kids could assemble their creations that they thought of and also be able to take apart the blocks at the same time. So they had to create a new system in order for that to be easily done. And thus the Legos were created. When you're creating a system, you want to have an idea of how it's going to function and how people are going to use that system. So for example, I'll show you one of my systems here. This here is a battery mount for a Hoover battery, and it clicks right in. And in order for me to create something like this, I had to think about, well, how are they going to release the battery and also attach the battery, and then where is this going to be mounted? So I incorporated two screw holes in there, and also where the clips will slide in and engage these gaps here. And I also had to measure the tolerance for it to slide on these rails here. So knowing all those together, I had to create it to where it locks in. There's not a lot of movement in there yet. It's also easy to remove. So creating systems, knowing how you want those systems to function, and also using those systems. These are a part of engineering. So guys, I hope you learned something from this video, and there'll definitely be a part 2 on things that I learned about engineering. And guys, I just encourage you to take some of these things that I have observed, and hopefully they can help you become better engineers. So definitely go out there, experiment. Don't worry about the mistakes you may make. Just keep trying and trying until you perfect what you're trying to do. So guys, if you'd like to support the channel, support links are in the description below. And I really appreciate you guys tuning in. Make sure you like the video on the way out. And guys, I'll see you on the next video. Take care.